Most people solve this problem in a wrong way and waste order of n space complexity. I'll show you the trick that top companies actually want to see this. Here's the challenge. You are given a two sorted linked list and your job is to merge into one sorted linked list like this. Sounds simple, right? But here's the catch that most people miss it. The first approach would be a kind of obvious, okay? But this is what 90% people do this in the interview. What they actually do, the first step would be that they copy both the linked list into an array like this. Now the second step would be that they will be sorting this array by using either merge sort or quick sort like this. And the third step would be they will be creating a new linked list with the help of this array like this. Seems logical, right? But look at this. Here the time complexity is very huge. Why? First, they will be copying both the linked list into a single array. Okay, so here the time complexity would be n plus m. Okay, now after this they will be sorting it by using either quick sort or merge sort. So over here the time complexity will be n plus m into log of n plus m. Okay, and after sorting they will be creating this linked list by using this array. Okay, so over here the time complexity will be n plus m. Among these three, the dominant one is this. Okay, so the time complexity would be order of n plus m into log of n plus m, which is very huge. Okay, so and also the space complexity will be order of n plus m because we have taken extra space first for creating the array, and second we have created a new linked list as well. Okay, which is slow, and here we have taken the extra space. But wait, the interviewer just said you can do this in constant space. So this approach fails at the constraints. Okay, so we need to do something better. Okay, so the second approach. Now here's the trick that makes interview happy, that we can do this by using the two pointer technique. Now why does it work? Because over here both the linked lists are in a sorted manner, right? So we don't need to sort it again, we just need to have a clear pointer manipulation. Here are the two linked list. Okay, now first of all what we need to do, among this first node, okay, we need to find out that which one is the minimum. Okay, and that will be our new head. Okay, so among this I do see this one is the minimum, right? Because the value is 1, so this will be my new head. So I will be having head pointing to this. Now see, I will be having two pointers, p1 and p2. Okay, so as I know that among this one is the minimum. Okay, so I will be shifting this p1 to the next point node. Okay, and I will be having a new temporary variable in which it will be pointing to the minimum value. Now again I'll check among these two which one is minimum. Over here I do see that 2 is minimum. Okay, now with the help of the temporary variable I will be deleting this and I will be doing temp.next is equals to p2. Okay, so this node will be pointing next to this. Okay, because among this 2 was the minimum. Okay, and after pointing I will be shifting my p2 to next node, and after that I'll move my temp to this node now. Okay, now again I will be doing the comparison of p1 and p2. Over here I do see that p1, the value inside in p1 is smaller, so what I'll do, I'll delete this pointer and I'll have this at p1 now, because among this 3 was the minimum. Now after moving or after pointing to the P1, I will be moving this P1 to the next node and temp over here. Okay, now again I will be doing the comparison of this P1 and P2. Over here I do see that 4 is minimum. Okay, so I will be deleting this pointer and pointing to the P2. Right, after doing this, P2 will be pointed to the next node and temp will be pointing to here. Okay, again I'll do the comparison among 5 and 6. Over here I do see that 5 is minimum. Okay, so what I'll do, delete this pointer and point it over here at P1. After pointing, what I'll do, I'll move my P1 to the next and temp to next. Got it? Okay, so basically what we are doing, see, first we are comparing P1 and P2. So if P1 dot val is lesser than P2 dot val, if this is the case, okay, so temp dot next is equals to P1. Okay, I need to make temp dot next pointing to P1, and after doing this I need to shift the pointer to P1 dot next. Okay, so P1 will be P1 dot next. Now if this is not the case, that means if my value present in P1 is not minimum, it means that value present in P2 is minimum, right? So temp dot next is equals to P2, and I need to shift P2 to P2 dot next. And over here, if you take a look, in both the cases I am shifting my temp as well. Okay, so over here I will be having temp is equals to temp dot next. Now if you take a look till temporary, okay, this is the head 1, it is pointing to 2, 2 is pointing to 3, 3 is pointing to 4, and 4 is pointing to 5. Okay, now I'll again do the comparison of 7 and 6. Okay, over here I do say that 6 is minimum, that means the else part. Okay, so make temp dot next as P2. Okay, so it will be get deleted, so I will be pointing temp dot next at P2. After doing this, we need to shift the P2 to the next, so P2 will be pointing over here now and have temp as well, shift the temp as well. Okay, again I will be doing a comparison of P1 and P2. Over here I do see that 7 is the minimum, or the 7 is the smallest. Okay, so do temp dot next as P1, so delete this and point temp dot next as P1, and after doing this, shift P1 and shift temp as well. Got it? Now I'll again do the comparison. Over here I do see that 9 is minimum, right? So temp dot next will be pointing to P1, okay, which is already there. Now what I'll do, P1 will be P1 dot next, so P1 will be pointing to null. After that I do need to do one thing, that is temp is equals to temp dot next, so temp will be pointing to this. Okay, now over here I do see that among P1 and P2, P1 is pointing to null. Okay, it means that the values from here, okay, the values which are from temporary to the last is actually lesser than P2. Okay, the value present in P2. So basically what I need to do, if either P1 and P2 is null, I need to terminate the loop, and after that I need to check who is not null. So I do see that P2 is not null, so I just need to do one last thing, make temporary dot next pointing to P2. That's it. Okay, so if you take a look, after 7 the largest is 9, and after 9 the largest is 10, and then 12. That's it. Okay, so here is a pseudocode will be looking like. See, P1 will be head 1 and P2 will be head 2. Now I'll check if P1 dot val is lesser than equals to P2 dot val. It means that among these first nodes, okay, P1 is minimum, right? So new head will be P1, okay, and I need to shift my P1 to P1 dot next and have temporary pointing to head. Okay, so this is for comparing the first nodes. Now else part, it means that P2 is the value present in P2 is minimum, so head will be pointing to P2 and P2 will be P2 dot next. So I'm shifting it, and temp will be head. Okay, now here comes the while loop. While P1 is not equals to null and P2 is not equals to null. If this is the case, then we need to follow this procedure. Okay, now among this P1 and P2, if any of them is found out to be null, then I need to terminate this while loop and I just need to check among this which is not null. If P1 is not equals to null, then have temp dot next is equals to P1, or else I need to check if P2 is not equals to null, then do temp dot next is equals to P2. So in the above example, we got to know that P2 was not null, right? P2 was not null. So what I did temp dot next is equals to P2. That's it. Okay. And I believe this is it. Now, why this is a brilliant? See, look what we achieved. Here we are touching each and every node. Okay. So this number of node, here the number of node, let's say, is n, and here the number of nodes are m. Okay, so since we are touching each and every node, so the time complexity will be order of n plus m, and here we can see that we didn't take any extra space, so the space complexity will be constant. Okay, so this is a difference between a junior and a senior developer answers. Now the key insight about this, okay, remember this pattern. When both inputs are in a sorted order, you don't need to sort it again, just merge them with using two-pointer technique. Now this same technique works for merging sorted array, merge sort algorithm, as well as finding the medium of two sorted arrays. Now if you master this pattern, you have unlocked multiple problems over here. Okay, so I believe you got this approach. Okay, if you didn't, please try to dry run it by yourself. If this lecture helped you understand the concept better, make sure you like this video, share it with others who are learning, and don't forget to subscribe for more easy DSA explanation. Thank you so much.